Hello friends, in this video we will try to understand the concept of convolution using two rectangular functions. So the problem goes like this. So we are interested in finding the evaluation of the convolution of two rectangular functions x1 of t and x2 of t, and both are having different width. The first rectangle is having a width of 1 and second rectangle is having a width of 2. Okay, so we are interested in convolution of these two signals, and let us assume the resulting signal is x of t. Okay, the resulting signal is x of t. So before we start evaluating the convolution, again we have to consider the three important results which we know. So first one is the convolution of any signal x of t with Dirac delta function is the same signal, and the second result is convolution of any signal with derivative of Dirac delta function will give you the differentiation of the corresponding signal x of t. And as a third result, a convolution of any signal x of t with unit step function will result in the running integral, which is equal to integral minus infinity to t x of tau d tau. Okay, so as if you substitute x of t to be u of t in the second result, we can see that u of t convolved with delta dash of t, which is nothing but the derivative of unit step function, which is nothing but the Dirac delta function. Okay, so derivative of unit step function would be Dirac delta function. Okay, so let us start trying to evaluate the convolution of the original signal. Okay, so as given in the first result, we can write any signal x of t as convolution of x of t with Dirac delta function. Okay, x of t convolved with Dirac delta function, but for us x of t is nothing but x1 of t convolved with x2 of t. Okay, and this whole thing is again convolved with Dirac delta function. Okay, so just now we have seen that the Dirac delta function can be written as u of t convolved with delta dash of t, and hence our x of t would be equal to x1 of t convolved with x2 of t, and the Dirac delta function can be replaced with u of t convolved with delta dash of t. Okay, and because the convolution operation is commutative and associative, so we can interchange the order of the convolution, and hence we can convolve the first signal x1 of t with derivative of Dirac delta function and x2 of t with the unit step function. So the given x of t can be written as x1 of t convolved with delta dash of t, and this whole thing is convolved with x2 of t convolved with u of t. So all these things are happening because of the convolution operation satisfying associative and commutative properties. So finally this simplifies to d by dt of x1 of t convolved with integral of x2 of t, integral minus infinity to t x2 of tau d tau. Okay, so finally the convolution, the signal, final convolution signal x of t can be written as derivative of x1 of t convolved with integral of x2 of t. Okay, so now let us try to finally solve the problem. So note that x1 of t is a rectangular function from 0 to 1, and hence derivative of Dirac delta function can be the derivative of this rectangular function will have two Dirac delta functions at 0 and 1, and the details of which can be obtained by looking at the video given in the above link. Okay, and similarly the integral of rectangular function also we have derived in the above link, so you can go through that. So and hence we can see that our signal x of t is nothing but the derivative of x1 of t, which is rectangular function, the plot of which will look like this. So you will have a Dirac delta function at origin with strength 1, and we have another Dirac delta at 1 with strength -1. So this is our x1 dash of t, and this fellow is convolved with integral of the rectangular function, which would be of this fashion. Okay, so you will have a positive slope and then a constant value. So this is 0 and this is 2 and this amplitude is 2. Okay, so this would be the integral of x2 of t. So as said earlier, so we have a link where we have described where we have evaluated the derivative and integral of the integral of the rectangular function. Okay, so this finally boils down to, so if it, here we have a Dirac delta function, this fellow is convolved with, now we will use a distributive property of the convolution, and hence the convolution of this Dirac delta function with this whole function will give you the same function, because convolution of any signal with Dirac delta function is the same signal. Okay, okay, and the corresponding amplitude would be 2. This is 0 and this is 2. Okay, similarly convolution of shifted Dirac delta function with this function will shift the signal by 2 units. Okay, so we'll shift the signal by 2 units. Okay, the signal shift the signal by 1 unit, because we have a shifted Dirac delta function with a shift of 1. Okay, so the plot will look like this. Okay, so this is 1, and because it is shifted by 1 unit, this fellow would be 3. Okay, and this would be, the amplitude would be 2, and the equation of this straight line would be t, and the equation of this straight line would be t minus 1. Now we have to subtract the second signal from the first signal. So how does the plot look? So finally, so if you look at this plot from 0 to 1, equation of this straight line is t, and from 0 to 1 we don't have anything, so t minus 0 would be t. So from 0 to 1 you have a straight line t, and then so from 1 to 2 equation of this straight line is t, and from 1 to 2 equation of this straight line is t minus 1. So t minus of t minus 1 would be plus 1, so t will get cancelled out, so minus of minus 1 would be plus 1, and this continues till 2. Okay, then from 2 to 3, from 2 to 3 equation of this function is 2, and from 2 to 3 equation of this function is t minus 1. Okay, so and hence we have 2 minus of t minus 1 would be equal to 3 minus t, which is of a negative slope, and it continues like this. So equation of this straight line would be 3 minus t, and this continues up to 3. So beyond 3 what happens? So beyond 3 this fellow is 2, and beyond 3 this fellow is also 2. So once you subtract, the final answer would be 0. Okay, so beyond 3 our function x of t would be equal to 0. So finally this would be our x of t, which is a trapezoid. Okay, so let us summarize what we have got. So we have seen that convolution of a rectangle from 0 to 1 with amplitude 1 with another rectangle amplitude 1 from 0 to 2 would be equal to a trapezoidal signal from 0 to 3. Okay, so this is 0, this is 3, this time limits are 1 and 2, and equation of this straight line is t, equation of this straight line is 3 minus t, and amplitude would be equal to 1. Okay, so hope this problem helps you in understanding the concept of convolution of two rectangles using differentiation and integration properties. Thank you.